Convert standard notation to scientific notation. George receives reports from the hospitals in the United States stating the number of times PALS was used to revive a pediatric patient. After processing the data, George determined that there were 523,000 interventions used in the previous year. What is this number in scientific notation? So for the scientific notation format, it is number times 10 raised to a number, which is represented as A. And to find the exponent, we must look at the standard notation and location of the decimal. So for this scenario, our decimal point is after the last digit. Then we must, establishing the first number, move the decimal so that only one number is to the left of the decimal. Determining the exponent, count the number of times that the decimal is moved. And so when we move the decimal, which is right here, we'll go 500. So we go from here, this decimal, we go 1, 2, 3, 4, 5. So this gives us a new number of 5.23000. So this is our first number in our scientific notation format. Next, we move the decimal 5 times, so this becomes our exponent. So now we need to decide on the integer. If the decimal moved to the left, then the exponent is positive. And if the decimal moved to the right, then the exponent is negative. This is the opposite thing with converting to standard notation. So since we move to the left, our integer is positive. So we would have a times 10 to the 5th power. And then we do not need these extra zeros here because they are meaningless in this situation right now. So we would actually convert it to 5.23 times 10 to the 5th power. This is our scientific notation. Now let's look at another example. In addition to knowing the number of PALS interventions, George is also researching the outcome of the patients receiving the intervention. He determined that there is a 0.033 survival rate for patients who are under 1 year of age and have needed PALS intervention. What is this number in scientific notation? So we'll write out the number, and we want to move the decimal so there's only one number to the left of it, like an actual number, because right now it's just 0. So we would move this decimal to the right. We go 1, 2, and put it right there. So this new number becomes, and then we multiply it by 10, and since we move to the right, this means that we have a negative exponent, and we moved it 2 times, so it's negative 2. So we can drop this first 0, as it's a leading 0, and we don't need it, so we go 3.3 times 10 to the negative 2. So this is our solution. And so remember, when converting to scientific notation, there are 3 steps. First, move the decimal so there's only one digit in front of the decimal. Second, count the number of times that the decimal moved. this number becomes the exponent for the number 10. And lastly, determine if the exponent is positive or negative, and if the decimal moved to the right, the exponent is negative, and if the decimal moved to the left, the exponent is positive.